So now we get to where I finally feel like we're going to be able to have fun again. Okay? So we had fun the first week. Now we're at the... This was a bit of drudgery that we had to work through. We worked through it, and now we're going to have fun again. So now we're going to go over 3 different topics. Well, I'm going to go over 2 of them. Then you're going to do one for homework. So we're going to go over linked lists. We're going to first go over singly linked lists. Then I'll implement doubly linked lists for you. And then you're going to use... a circular linked list on your homework to do some very interesting things. Alright? I'm still deciding on whether to use the assignment I've used for a while or to do something new. So, a singly linked... So, alright. If we go over here, right, this is a nice rundown of all the runtimes that I just went over in the last video. The set and get methods execute in constant time on an array list. But inserting and removing elements... It's not at the end, right? It takes linear time to add or remove any element from anywhere except for the end. Right, because if we're inserting an item into an array list, if we add an item to the beginning, we have to shift over n items. If we remove an item from the beginning or from the middle, we have to shift over n or n over 2 items. Right? Now, adding to the end is usually constant, but the worst case scenario is that you might have to reallocate. I would come back to this slide. This might be something worth like 20 points on an exam or something. Did I say that? Yes, I did. You should totally study this slide. There's going to be a 20, I generally put a 20-point question around this about comparing the performance of stuff. Okay, so a singly linked list, it will be the inverse of an array list in performance. It can add or remove elements to a known location, such as the beginning or end, in constant time. But if you're trying to do something to the middle of a linked list, it's going to take O of n time. Right? Array lists are limited because its add and remove elements require you to shift O of n items. In a linked list, we just can simply add items to the beginning or to the end, very simply. Now, the way a linked list works, rather than it being just one chunk, right, of memory, just allocated all at once. Instead, the way a linked list works is a linked list is linked. It is a scavenger hunt through your computer where each item points to the next item in your list. Right? Let's get a canvas up here because this is actually one thing that I can do drawing on, and it actually makes sense. Alright. A linked list. So an array list looks something like this. Big chunk of memory divided into indices. Right? Assuming my computer just doesn't randomly slow down while I'm trying to draw stuff. Right? And so on and so forth. Right? A linked list, on the other hand, is a bit different. In a linked list, each item or each component of the list, each item in the list, has a way that points to the next item in the list. So rather just being contingent bits of memory, it can tell you to jump to this memory location, to jump to this memory location, or to jump to this memory location, or to jump to this memory location. Right? It's essentially a scavenger hunt. Right? And in a scavenger hunt, typically what you do is you go and find something, and that something also is not just a thing you find, but it also has the directions to find the next item. Right? And so what this means is that so long as you know at the typically what we do is we keep track of the beginning item, what we call the head of the list. Okay? And then we keep track of and then later on we'll start keeping track of the last item in the list called the tail. For right now, for simplicity's sake, we're just going to keep track of the head for a while. And so as a result, it becomes very easy to add items. To just simply add an item to the list, you create what's called a new node, which is what's going to contain these things. And we just simply attach it as we give directions to find what was the former head of the list. And now we say this isn't the head anymore. This is the head of the list, right? We make this the new starting point in our scavenger hunt, right? To add a new item and make it the new tail, we just simply create a new node, which is, again, what we call these items in the list. We let what's going to be the old tail point to the new end of the list, and we say, this is the new tail. That should hopefully make sense, right? It's a scavenger hunt through this. Now, how do we do this? We use, believe it or not, what we call our boxes. We use these list nodes. A node can contain a data item, one or more item, and one or more links. In other words, a link to the next item, the directions on how you find this item. Now, this is where, and it's these nodes that are is more than the big O notation, is the tripping point for a lot of students. Okay, it's very, very, very important that you remember something over here, right, as we go through this. So let me go ahead and start coding this up. But I need to go ahead and destruct array lists, new package, linked list. Oops, move this over here, refactor. Okay, so I'm going to reveal to you what I know from experience of watching students struggle with this. They don't struggle with the big O stuff, especially once you get my worksheet and work through it. The worksheet makes a lot of things clear. Okay. We are going to do so now let's go ahead and see. So the thing to remember is that I've got this thing, let's say I've got this string here, and I've got hello. I've got this string S, and I've got this string Q over here is equal to S, right? The memory location, this isn't storing hello, or rather, S doesn't necessarily store hello. Literally what it stores is a memory location. It restores a reference to hello. And what we do here in this operation is that this operation over here takes the memory location on the right and assigns it to the variable on the left. The memory location on the right gets stored in the variable on the left, and that's very important you keep this in mind as we go through these.